In Fisher projection, we have to convert three-dimensional molecule in two dimensions. Suppose this is a three-dimensional object. When we can draw the diagram of three-dimensional object in two ways. Either we can use wedge and dash formula. What I mean? Suppose this is carbon. We can represent molecule like this. This is known as wedge and dash formula. For example, I take this example. What I have done here, when I hold molecule like this, when I am holding molecule like this, see here, this vertical line is white, this orange, pink is going away from the viewer, this blue line is towards the viewer. Imagine that there is a plane here. If you imagine there is a plane here or a plane is passing through this point, blue is towards viewer. See, this is towards the viewer. Pink is away from the viewer, and these two are in a plane. Okay. Now, if you see here, this vertical line is white, this line is red. When we write solid line, keep in mind this solid line is towards the viewer. Towards the observer. In this model, this blue line is towards the observer. This is blue, and this line, whenever we write dash line, it means that it is away from the viewer. And in this diagram, this is orange. This is the general way to represent a three-dimensional object. Now, often we have to convert three-dimensional object in two dimensions. Now, whenever we have to convert, what we have to do? We have to keep in mind that we have to rotate molecule like this. We can hold molecule like this. When you hold molecule like this, the two bonds which will come on the vertical. What I mean to say, let us see here. You can see the projection here. You can see the projection of molecule here. You can see there are four bonds. You can see its projection here. This line is at the top. This line is at the bottom. This line is left or right. Or what I can say that if I am holding molecule like this, it will have four bonds, two bond horizontal and two bond vertical. But keep in mind, if I am holding like this is a wrong way to hold the molecule. The line which will be at the vertical line, for example, I can draw molecule. We often draw molecule like this. You must have seen the organic compound that we often draw molecule like this. When we draw molecule like this, the center represents carbon. Right hand side is this, left hand side this will come to the vertical. You can imagine that we have to draw like this. But this is a wrong way to hold the molecule. This horizontal line should be towards the viewer. And this line should be away from the viewer. Therefore, if I am holding molecule like this is wrong. I rotate the molecule and you have to find out whether I am holding the molecule in right way or wrong way. Suppose I am holding this molecule in this way. This is the correct way, because see, when you project, these two lines will be on the vertical side and these two will be horizontal. Those who are coming in the vertical side, they are away from the viewer. Suppose I am holding molecule like this is wrong, because when you project this will be on vertical side, and those who are coming on vertical side is towards the viewer. It should be away from the viewer. If I rotate molecule like this is correct projection. Now, how to do this? How to do this? Because it is often very difficult to convert two-dimensional figure into, three-dimensional object into two-dimensional. There is a very simple trick. What is the trick? What you do? You put the line which is away from the viewer. This is away from the viewer. You draw the fourth position. The bond which is away from the viewer, it is orange here. You put orange here. Now you forget that orange is here. Always you have to put the line away from there at the bottom. Now we have remaining three positions. What you have to do? You imagine that orange not here. You either put in clockwise or anti-clockwise. For example, we have blue here, white here and red here. In clockwise, similarly blue, white and white. You have converted the two-dimensional object, the three-dimensional object in two-dimensional. I would like to give you some example. See it carefully. Suppose somebody has drawn a three-dimensional object like this. This is CS3, this is OH and this is pH. Now see, this is a three-dimensional representation of a molecule. What we have to convert? We have to convert into two-dimensional. What you do? See, this is, let me explain the molecule. The molecule is like this. First you have to clearly visualize what is the real molecule. Whenever we write a molecule or represent a molecule in single line, it means these two are in the plane. See, these two are in the plane, they are in the plane. The line that is drawn by solid line, it is towards the viewer. This is OH, solid line OH. And this is away from the viewer, which is white line in this manner. Now, if you see here, just compare this. C2H5 is blue line here, pH is red line. These two are in the plane. Towards the viewer, it is orange. It is OH, which is represented by solid line. Away from the viewer, white, which is represented by CS3. Now, what you have to do? You have to convert this into two dimensions. Let us do this thing. See, which group is going away from the viewer? It is CS3 which is going away from the viewer. What you do? You put 4 position here, put CS3 here. Now forget CS3. Imagine that CS3 is not present here. If CS3 is not present here, we have 3 groups. Just put in any direction. You can start from anywhere. You can start with C2H5, you can start with pH or OH. Let us start with C2H5. First, you have 3 positions to be filled here. See, 1 position, 2nd position and 3rd position. Again, we will move in the same direction. First, we have C2H5, then we have pH, then we have OH. This is the very easy way to convert 3-dimensional object into 2-dimensional objects. That's all. Thank you.